Alright, the last section in 2.4 is dealing with complex solutions of quadratic equations. So there's a little bit of setup for this one, but not too bad. So again, complex solutions of quadratic equations. So the first part of this one, we're going to kind of go backwards a little bit just to take a look at some different setup here. And one of them is revisiting that principal square root. It's just this time we're going to look at it in terms of complex. So we could define this one by saying negative, or square root of negative a would be the same as square root of negative 1 times a, which would be the same as square root of negative 1 times square root of a, and square root of negative 1 is just I. So we could get this as I times square root of a. So again, we're going to pull this one out as the common look that we're going to solve most of these problems with. Now, this is the way when I do it freehand, I like to write the I out front so I know that it's not under the radical. In the book where they can type this thing out, you're usually going to see this like a coefficient and the I after it. Doesn't matter to me which way it's written, it's just a matter of I tend to write kind of fast and it gets sloppy once in a while. This way, like I said, guarantees that I know where the I is, whether it's outside or inside of the radical sign. So that's why I like to write it that way. So a couple things that we can do with problems like this. You could have one square root times another square root, and we can do this multiplication. Now, a lot of people are tempted to go right away, oh yeah, square root times square root is a single square root, and negative times negative is positive. But one thing you got to be careful of is, remember, this is a complex number right here. We have to pull that I value out. So that's actually going to be I times square root of 3 and I times square root of 12. So if I simplify, I times I is actually I squared. Now I can do my multiplication and do square root of 3 times square root of 12 is square root of 36. So two things simplify here. Square root of 36 is 6. That's our idea of our principal square root. Even though negative 6 times negative 6 is also 36, we're going to deal with principal square root. And I times I is negative 1. So I actually get negative 1 times 6, or negative 6. So if we would have done this right away and just said, hey, negative 3 times negative 12 is 36, square root of 36 is 6, we actually would have got the wrong solution to this one. So be careful when you set that up. Alright, what about another one here with we did a multiplication, let's do a subtraction. So square root of negative 48 minus square root of negative 27. Now I can't just put these together and say, oh yeah, it's negative 48 minus 27, or minus a negative 27. So I got to deal with these by pulling that I out as well. So I is going to come out square root of 48. Subtract, pull I out for that negative 1, and then I get 27. Now remember, we've done a lot of different ways with setting up this square root. A lot of you've done the trees, so I could do that and say that's 2 times 24, 2 times 12, 2 times 6, 2 times 3. Again, this is the longhand way of doing it. Obviously, a lot of you, if you're real comfortable, have found shorter ways. But this one, there's a pair of 2's and another pair of 2's. So it's going to actually turn into 2 times 2 is 4. That's on the outside. Times square root of 3, which didn't have a partner, times the I that we pulled out. Now over here we're going to do subtraction, And same thing. 3 times 9, 3 times 3, pair of 3's, and a leftover 3. So we're going to get 3, leftover 3, and I. So now they're both in terms of square root of 3i and square root of 3i. Well, how many square root of 3i's do I have? 4 of them here, take away 1 of them here, and I'm left with 1 square root of 3 times I. So that can be a little tricky because we've got things underneath. We've got radicals, we've got numbers in front of the radicals, we've got letters. A lot of different things that can show up on that one. So just take your time, step by step. Things usually turn out alright with it. Alright, let's take a look at another one here. And this is another one that was cut that we've looked at already, but it's got a few more components to it this time. So this is another one of those that looks like a plus b all squared. So I would say square multiply square. So square the first plus, we're going to multiply 2 times -1 times square root of -3, and then square the last like that. Now a couple things that I would probably do different on this one. Starting out here, pretty simple, -1 times itself is just 1. Now here again, simplify this so that I get -2. I would pull out the I and have square root of 3. So that one's not too bad. Now here again, I would pull out the I, square root of 3, and now square that. Just to play it safe with our signs. So now I've got this. Over here, I squared is -1, and then square root of 3 times square root of 3 is 3. So if I simplify this, 1 minus 3 is -2, minus 2 times I square root of 3. So again, not too bad. Just got to keep a few things straight as you go through this. Alright, last one. What about quadratic equation? How does this all apply? Well, actually it applies quite a bit to the simplification of your final answer. A pretty simple look at one of these might be, we actually started out the problems with these, a quadratic with a constant. Here I would just subtract 4 from both sides. I'm going to get x squared equals -4, and then I'm going to have to do square root and plus or minus square root. So I'm going to get x equals plus or minus square root of -4. And again, that negative is just going to be my I. And square root of 4. So if I want to look at, I'm going to show this as all the steps. This is going to become I times square root of 4. And then square root of 4 we know is 2. So there's 2 solutions. 2i and -2i would be the roots or the zeros of this. Now again, some of these steps you're going to combine as you get more comfortable with that. That's fine. I just wanted to show you each step so you can see where all the parts are coming from. Alright, one more that's not quite as quick as this. 3x squared minus 2x plus 5. Not really a short way of doing this, so we probably jump onto quadratic formula. So we would have x equals opposite of b plus or minus square root b squared minus 4 times a times c all over 2 times a. And here's why we need to know how to simplify these, because this time if you look at the radical, I can draw a radical. So this time if you look at the radical here, we're going to get a negative on this side, and we're going to get a -60 all over 6. So when I simplify that, I get 2 plus or minus square root -56. So because of that negative, that's going to be an imaginary number. So I'm going to have to pull the I out front. So let's up here where we get a little more room. X equals 2 plus or minus. We'll pull that I out. Square root of 56 all over 6. And then that square root of 56, you can do the tree or the repeated division or whatever way you want to do that, but just to save time here for you, we'll pull that out. And that's just going to be 2 times square root of 14. So the 2 times the I that's already there, square root of 14 all over 6. So nothing magical there. It's just I saved you this trip of doing the tree with the 56 and just jumped right to the answer. So now this is like one of those problems on one of the earlier pages. Since we're working with complex numbers, I would maybe just do this and say, yep, divide by 2, divide by 2, divide by 2, and just get 1 plus or minus I square root of 14 all over 3 is one possible solution. 3 is terrible. The other way to look at this would be 2/6 plus or minus 2I squared of 14 over 6, which would basically just turn into 1/3 plus 1/3 or square root of 14. Well, let's look at that one. If I split this in half, it's going to be 1/3 plus or minus, and the numbers are square root of 14 over 3 times I. And the only reason this is good is because it again looks like A plus or minus BI. So just another option for your answer. And that takes care of our section on complex values.